Hi and welcome. Thank you for joining us today, where we're looking at the future outlook for agriculture through the use of AI and agri-robotics. For those of you that don't know, my name is Wendy Hewitson, and I'm the AgriTech Programme Manager for Barclays Eagle Labs. Now, because we are doing this presentation today, I do have a short mandatory disclaimer to read out to you, and then we'll get on with the event. So today, we have asked Simon Pearson from Lincoln University and Mihai Ciobanu from Fresh Forecast to join us today to provide us with some hints, tips and tricks on the future outlook for agriculture through the use of AI and agri-robotics. These topics discussed are an overview of your options for you to think about and to help you with your independent research and business decisions, so they aren't intended as recommendations or advice. Please remember as well that your business has its own individual circumstances, so the statements and views expressed may not be applicable or suitable for your business. So as I said, thank you very much. And today we're looking at the future outlook for agriculture through the use of AI and agri-robotics. But firstly, I want to give you a bit of background around who Barclays Eagle Labs are and the AgriTech programme. So Barclays Eagle Labs is part of the UK's largest business incubator network. We've got 25 physical sites across the UK, from down south in Guernsey and Jersey up to the far north in Aberdeen. And we have one goal within our Eagle Labs, and that is to help the creation, innovation and growth, plus the fast scale-up of tech-enabled technologies. So we're looking at the acceleration of UK businesses. In an agri lens, that is connecting agri-tech startup businesses to research and development expertise, connecting the farmers to the supply chain, and the supply chain right across the board to all of the academia and businesses to support agriculture. We also look at collaborative innovation, where we aim to stimulate innovation and collaboration across the food supply chain, no matter where you are within that food supply chain. And today, the most important one for me is the Industry 4.0, where we look to demystify Industry 4.0 for our farming clientele, to become the voice of the farmer to the industry, and also enable technology to understand the farming issues and vice versa, the farming to understand the technology that is out there. So our vision is to become the #1 bank for positive innovation within agriculture. We aim to support the UK's food supply chain to become the most sustainable ecosystem in the world through the demystification of technology and encouraging that collaboration pan supply chain. So literally, we want to look at feeding the planet without wrecking it. So when I talk about Agriculture 4.0, what is it? What does it mean? For me, it's one simple sentence. It is a tool to support the farmer, not to replace them. And there's lots of elements to this, but the key ones that we will focus on in any of our presentation, anything we do, is that it's around about looking at productivity, sustainability, efficiencies, and time-saving elements for that farming industry. So as I said, we're looking at AI and robotics. So why robotics? So this is just a general overview of where we're at now and what we're doing. So the government has committed a £90 million investment supporting the idea that AgriTech is a burgeoning market, the transforming food production challenge through the industrial strategy. So we are proud to be exploring the use of robotics in this important sector. It's employing almost 4 million people and is larger than the automotive and aerospace sectors combined. Agri-tech companies are already working closely with UK farmers, using technology, particularly robotics and AI, to help them create new technologies and herald new innovations. So this is truly an exciting time for the industry, as there is a growing recognition that the significant challenges that are facing global agriculture represent unique opportunities for innovation, investment, and commercial growth. So the reasons for the change in the food production, what are we doing? Agri-food is the largest manufacturing sector in the UK. It supports a food chain that generates over £108 billion per annum, with an astounding 3.9 million employees. So it's truly an international industry, and we export circa £20 billion of UK manufactured goods. However, we understand that the global food chain is under pressure from population growth, climate change, political pressures, which affect things such as migration, population drift from rural to urban regions, and the demographics of an ageing global population. And these are the challenges that are recognised within the UK industrial strategy. So there's lots of uses of new technology, and the agricultural robots market is projected to grow from $4.6 billion in 2020 to circa $20.3 billion by 2025. That is an expected growth of a compound annual growth rate of 34.5%, which is quite astounding. So the vision, what is the vision? The vision for us and the vision for everyone involved within agriculture is a new generation of smart, flexible, robust, compliant and interconnected robotic and autonomous systems, where they will work seamlessly alongside their human co-workers in farms and in food factories. So to deliver this vision, the research and innovation needs to include the development of robust robotic platforms suited to the agricultural environments, improved capabilities for sensing, perception, planning, coordination, manipulation, and grasping. So it's all about the learning, adaptation, interoperability between robots and existing machinery. So the human to robot collaboration needs to include things such as health and safety and issuer and user acceptance. So what are we looking at? When we look at it, technology adoption is likely to occur in measured steps. Most farmers and food producers will need these technologies, and they will need to be introduced gradually alongside their existing food or production systems. So there will be a transition period in which humans and robots will work together, first simple and then along more complex parts of work, which means that these jobs can be conducted by robots, driving the productivity and enabling us as humans to enable us to move up the value chain. So there's many new technologies and techniques that are being developed. Some of those areas we have covered previously and some we're looking at today. And those include areas such as harvest management, field farming, including crop monitoring, plant counting and crop scouting. Also dairy and livestock management, such as livestock monitoring, precision fish farming, soil management, moisture monitoring and nutrient monitoring, irrigation management, weather tracking and monitoring, inventory management, and also, because of the influence at the moment, COVID-19's impact on various applications, including that of agricultural robots. So that is just giving us a quick overview of why we're looking at this and what sort of areas that it's going to be covering. So you've heard enough from me. We're now going to look at the future outlook for agriculture through the use of AI and robotics. My first speaker is Professor Simon Pearson, who's Director of LIAT and Professor of Agri-Food Technology from the University of Lincoln. So I'm going to hand it over. Hello, Simon. Are you there?
Thank you very much, Wendy. That's a wonderful introduction to what I want to talk about today. First of all, I just want to say how proud I am to be working with Eagle Labs on this initiative, and it's fantastic to see Barclays being so active and trying to promote our industry to the wider tech community. So thank you to Barclays, Eagle Lab especially. What I want to talk about today is future outlook for use of AI and agri-robotics across agriculture. And really, what I want to do really as a start is really follow on from Wendy's introduction, really just to highlight what I think are some of the fantastic opportunities for AgriTech in this space. And as Wendy says, this is we're working in a domain which is the UK's largest manufacturing sector, bigger than automotive and aerospace combined, £108 billion GVA, 4.5 million jobs. It's about 8%, I think, of the world economy is around agri-food. So it's a massive industry. And for anybody interested in the tech side, it's a great place to deploy your art and your craft. There's lots of opportunities. What I really wanted to go is to start really is to drill in where I think some of the mega trends are, and why what we're doing here today, and why there's opportunities for tech in this domain. And it really reflects some of the society and industry needs and challenges that we're facing. And what I've done here today is just highlighted some of them. This is not all of them. It's not a comprehensive list, but it's some of the highlights of things we need to think about. What are those massive societal problems that we need to solve? And I'll just sort of go through this list. But COVID-19 it's absolutely had a profound impact on all of society globally, particularly in the food chain. And one of the I think one of the positives around COVID is actually that the food chain responded to the post-lockdown crisis really quite well. And although there were times when food was short and there was some pseudo rationings going on, basically everybody was able to get food through the system, and that was a pretty good response from the food system. Why did it respond well? Well, one of the reasons it responded well is because the digital systems underpinning the supply chain actually worked pretty well. There's human intervention, rapid decision making, and fast response. That was great. What did COVID show, though? It did show that we need to improve those systems. There's lack of transparency of data. Systems, retailers, suppliers, manufacturers didn't know where their stock was at any moment. And there's absolutely no doubt that improving our digital systems to have more transparency of where the data is flowing across the food system, across our supply chains, would have helped in that response, and would help on day-to-day operational performance of our existing system. So lots of opportunities for connected data across supply chains to demonstrate where stock is, how it's moving, to track assets, etc. So big opportunity. Brexit, it's undeniable, and that's where robotics is going to have a really key role. We're moving into the new immigration bill in January, which may restrict the availability of EU migrants coming into the UK. There's this notion around low-skilled and low-paid workers. I don't like the terminology low-skilled, I have to say. These are low-paid workers who are coming into the UK to do jobs such as harvesting, fruit picking, vegetable picking, working food factories, 69,000 in farms, 121,000 in food factories. So very, very important flow of people that have been working in our industry and supporting the economy. That flow of people may dry up or may reduce in the future. So the industry needs to drive productivity in other ways, and that will be around, one of the responses will be around automation. So robotics is going to be really, really key to drive labour productivity in our sector. The other area we need to think about, just still some of the old challenges that we worry about, such as food poisoning. There's an image there in the top row middle of some Campylobacter spores. Some of the old challenges are still there, and they aren't going to go away. And we need to defeat those old challenges as we need to defeat COVID. And data is going to be very important in terms of tracking and tracing data through supply chains to check whether food is contaminated or adulterated. So data-driven solutions for traceability to underpin food poisoning are going to be key. We can't deny there's a massive impact of agriculture on the environment. We really need to think about how we reduce the environmental impact of agriculture. I think it's over 20% of greenhouse gas emissions are from agriculture, 70% of all fresh water that's globally is used in agricultural food production. We have to worry about contamination of the environment with fertilizers and pesticides and so on. And there's absolutely no doubt that data-driven solutions is going to be key. and the focus there is on sustainable intensification. So how do we get more per unit area of output whilst reducing the inputs? So how do we intensify production? That's going to be data-driven solutions. It's going to be using AI, more informed decision-making, sharper decision-making by farmers to reduce impacts. Absolutely critical. Then again, a post-Brexit impact, we're going to have more trade deals. This is a chlorinated chicken, but it's not really a story about chicken. It's really about competition for UK producers against imported goods. What is the response? What is the response of the industry to that competition? Well, it's got to be around productivity. So we've got to be world class. We've got to be producing highly productive foods that's competitive on a world scale, that protects us from imports, but also enables exports. That is, again, it's going to be data-driven solutions. Will be part of that. It will be investment, but it will be really more informed decision making, robotics, driving productivity, and all those issues. Food waste, still a massive problem. 7 million tonnes of avoidable food waste for the UK economy every year. We need to solve that. Every tonne we throw in the bin is several tonnes of carbon dioxide, and also the environmental cost that we need to think about. So we need to reduce food waste. How can we do that? Well, one of the areas will be AI, and it will be using AI to optimize inventory through food chains. So food is traditionally sold by retail, and that's supplied by food manufacturers and those in turn supplied by farmers, etc. So it's in a long supply chain. Matching inventory through that supply chain using AI has got to be one of the best ways that we can approach that challenge. So really trying to model through a supply chain how much food is required at different nodes in response to consumer demand, so that we don't end up binning waste when we have overstocks in the system. The egg, food traceability, I've already mentioned around food poisoning, but really the ability to track and trace food using new technologies such as distributed ledger technology, blockchain, call it what you may, is going to be absolutely crucial. We need to know where our food is. We need to be able to track it. If there's problems, we need to resolve it, but also we need to know where our inventory is at any point in time. So new technologies to underpin traceability are going to be absolutely key. The next one I got, systems of systems, is that sort of global planet that you can see on the right hand side of the screen, middle. What digital technology does, it enables us to join up systems of systems. So data from the food chain, we can from the food system, we can join up to data in the energy system or the water system, or any other system that we choose. And there's no doubt that as we go forward, the ability to connect our food system to other systems is going to be absolutely key. So to reduce environmental impact, so to reduce energy costs, we might need to take data from food production and link it to, say, national grid energy supply, etc., etc. So the ability to connect systems is going to be absolutely crucial to the future. Then we've got day-to-day trading issues, margin pressure and buyer power, I call it. That's not going to abate. So the industry is incredibly competitive. We've had a traditional system where the retail food market's been dominated by large retailers with significant buyer power, but we're now seeing lots of new entrants coming in, digital companies who might have pure play models coming into this sector. So there's lots of opportunities for new entrants in our food system. But the overall message is there's always going to be this continuous pressure to keep costs down and to maintain our competitive position. And that's going to be underpinned by digital tech. So there's going to be an onward pressure to drive labour and resource productivity. Robotics, creating new business models. This is this image, bottom row, middle, shows the Ocado robots, which are fantastic new innovation for depot fulfillment by Ocado. Same we're seeing in Amazon, but we're seeing lots of new robotic technologies all the way through the chain. So it's not just in the agri world where we work, but also across the whole supply chain. And these are creating new business models and great opportunities for tech startups to come in and really get a role in this sector. Trends around health, obesity, it's widely in the press at the moment, particularly around the COVID issue. But can data have a role in solving some of these problems? And surely it can, in terms of tracking and tracing calorie consumption by people, suggesting how people can change their diet, supporting them in a transition to a healthier lifestyle. So I'm absolutely sure that data-driven solutions can be key in that response. And then the final one I've just highlighted is we can't also deny that the population on the planet is increasing. We're going to have 10 billion people on the planet by 2050. All those people have got to be fed. They need fair and equitable access to food. So how are we going to get that food, though, from our planet, which is already under pressure? So sustainable intensification is going to be key, getting more yield per unit area with lower inputs has got to be key. So these are the mega trends which are drawing the need for AI and robotic solutions globally. They're not going to go away, and this is a great area for the tech community to step in and try and work with the agriculture community to get solutions. So what have we got? I just really wanted to highlight this one, just to show what the complexity of the system that we're operating in, but also what a data-rich environment it is, and where tech can come in. And what I've shown on the left is just just a system diagram of what I call the retail food system. And I think of the retail food system as a chain, and it's a decentralized chain with lots of actors across the system collaborating in a decentralized way. And so what we've got here is just a system diagram. It shows the inputs to the system, and those are money, that's data, it's things like water, environmental parameters, energy, etc. And that's then creating the hierarchical flow of food all the way from farmers. We've got some strawberry farmers at the bottom, some dairy farmers, some grain farmers. They're interacting with logistics companies, interacting with food processors, again interacting with logistic companies, interacting with supermarket depots, and then onward distribution to shops, and eventually food arrives to the consumer. So it's a highly decentralized network with many connections across that network, and it really is a very data-rich environment. There's lots of opportunity for AI, new tech, decentralized distributed ledger technology, connecting supply chain, use of IoT, etc., etc. So very data-rich. Well, I think one of the challenges, though, and it reflects the diagram on the right, is this notion that we need to engage more trust and actually get more sharing and access to data. And what this shows on the right-hand side is what we think is the next step to really drive growth within our sector, and it's to try and get more collaboration, more data sharing between all of these parties along that very complex supply chain on the left-hand side. So we think the key next step is really trying this governance and sharing of data to enable the tech community, the AI community, to develop these new opportunities and technologies to drive productivity. And how do we do that? So what are we focusing on now at Lincoln? We think there's three core things we need to think about. It's really on governance of data. So how do you govern that data in this complex system? How do you create interoperability for that data? So how do you share data across these complex chains? And who should be involved? The membership. Who should be involved in all that sharing of data? And we're very keen to talk to members of the tech community who want to be involved in initiatives around data sharing and trust, and we think that will unlock the next step for AI and robotics in the food sector around trust and sharing of data. So, and then briefly, just on robotics, I've mentioned this in my earlier talk for this webinar series, but we think there's 3 fantastic opportunities in robotics, and this is what we're working on. And there are many, many more opportunities beyond this as you go through the supply chain. We're very, very active in selective harvesting, and that's part of that really was brought about by initially changing the national living wage, increasing cost pressure on the industry. Then it was around Brexit, and now it's very much around COVID. And we urgently need solutions to drive productivity in the industry around labour. We're working very actively on soft fruit picking, strawberries and fruits, but I don't think there's hardly a fresh produce crop where we've not been asked to support the building of a robot. So it's a very, very big area, rich space, needs lots of innovation, lots of AI, lots of data, image processing, etc. So lots of space for tech companies in there. Then we think of crop care. We're very active. The middle bottom, that's on robotic weeding technology. Work with Garford's farm machinery very closely on this, and that's using cameras to identify weeds and then robots to kill them. And we're also working very closely with Agrirobotics. The top shows a 4-valve robot at Lincoln treating soft fruit with UVC, and that's a new way to reduce the use of fungicides. So UVC replaces fungicides. So what robotics is doing is showing new ways to solve old problems, and we're very excited by that because it does show us that there is a way to reduce the use of pesticides and synthetic chemicals in agriculture. So really good. But crop care goes beyond that. It might be monitoring plants as they grow in fields, monitoring carbon flux and all those sorts of areas. So fantastic space for tech communities to get involved. And then the final one, which we really now focusing on, is phenotyping. And what farmers need to do is relatively easy solutions to drive productivity. One of the best ways to do it is just select better varieties. So the farmer buys a better variety, has a higher yield and reduce inputs. How do you select those varieties? It's around phenotyping. And this just shows some of the work that's going on phenotyping worldwide and at Lincoln. And phenotyping requires field robots, but it also requires advanced sensors, use of AI, data analysis, huge data scales, so big data on a very big way. And that provides the insights that breeders need at scale to accelerate breeding, to find new traits, to market new crops to all farmers. So phenotyping, we think, is going to be really very, very significant. And those are just 3 of the opportunities that we're looking at in terms of robotics. So my message to the tech community is, please get involved. Many of you are involved, but this is a wonderful space, a very rich space where we can develop new solutions which will have a very, very tangible impact on agriculture, the environment and the community. So thank you for your interest, and I'll hand back to Wendy. Thank you.
Wow, thank you, Simon. It's such a wealth of opportunities. And as Simon said, it's not just one area. There are lots and lots of opportunities, with data transparency, operational efficiencies, phenotyping, really, really a massive opportunity for people to get involved within the sector. So that really does quite nicely lead on to our second speaker. And I have the pleasure of introducing Mihai from Fresh Forecast. And he's going to talk to us today around using AI to improve predictability in fresh fruit and veg. So, hi, Mihai, how are you today?
Hello, Wendy. Hi, thanks for the invitation. I'm really good, thank you. It was a pleasure to watch Simon's presentation. It's really great to see that sort of big picture overview of the big trends and the opportunities. I'm really delighted to be working in this space.
Fabulous. So do you want to tell the people at home and go through your presentation?
Yeah, definitely. So I think, what I probably do instead of going straight to the presentation is just pick up on some of the points from Simon's presentation, and then that would segue nicely into my deck, because I think there's a couple of points that really resonate with what we're doing. If you think about the trends, Simon mentioned, for instance, food waste, environment impact, and 10 billion people. And for us, and these are grouped together into an opportunity if you manage to improve essentially productivity without increasing the level of corrosion that you apply to the environment. So, while actually reducing the level of pesticides and so on. So, you intensify, you increase your productivity, but without the typical things that we're used to be associated with intensification. So that's an area that's very dear to us. So if you look at, for instance, food waste as a commercial opportunity, if a third of globally a third of what is produced is being wasted, what that means is you can, if you eliminate that, you can increase your output, your turnover, if you want, by 50% with the same cost structure. So that's the size of the prize. It's absolutely enormous, and what we're doing is trying to help farmers in that direction with forecasting tools. So 7 years ago, we started a company called Fresh Forecast. It does something very specific. It does forecast as a service in fruit and veg. So we try to create this this market. And you both mentioned the size of the agri-food. The UK agri-food industry, 180 billion a year. Just to give you a sense of our coverage today, so we do a lot of work in strawberries and in general in soft fruit, and we cover with various services a lot of the players in that market. So currently, about 75% of all the strawberries grown in the UK are one way or another handled through our systems in terms of forecasting with various services. So that's the soft fruit business is just under 1% of that UK agri-food business. So it is an enormous opportunity. We do work in other sectors as well, so salads and so on, and in other countries, but just to put us on a map somehow in terms of what we do. So we try to provide forecasting solutions in order to reduce waste, in order to help the businesses become more financially sustainable. And then that should ideally also make the environment, reduced environment impact and so on. So I think I wanted to segue from that. I'll come back to one of the other points, the other trends that Simon mentioned at the end of the presentation. But I thought it's nice to open with that. So just following on from that, I'm going to look at a couple of things from our experience, in AI and agriculture. How can artificial intelligence be put to good use in this sector? So first of all, just to limit the scope, to define the scope of what we mean by AI, because there are many definitions out there. And specifically, I'll be talking about narrow AI, which is supervised learning with well-delimited objectives. And that's what I'll be talking about when I mention AI. And there are two types of solutions: classifiers and regressors. And robots, for instance, we're not involved in robots, but robots will be using a lot of classifiers. Is this a fruit? Is this a ripe fruit? And so on. And we use a lot of we have classifiers in some of our tools, and we have regressors, for instance, in forecasting yield and so on. So we would say, is this the right day to be harvesting that salad field, for instance? And then we'll have a regressor saying, how many heads will be available, or how many tons of strawberry will be available in that particular field. So that's the scope of AI in the context of my presentation. And just to put the size of the prize on the picture, this is a study across customers from last year. And it shows the improvement in forecast accuracy by comparing the human forecast with the live forecast. So this is across strawberry customers, and you can see that the green line, which shows the distribution of error within the live forecast solutions, our machine learning application, is consistently in the same region as the best of the human forecast, which is the first hump of the blue distribution. And you see the human forecast, there's a whole bunch of forecast instances that go quite badly wrong. So essentially what you're getting, especially in the early years, is a forecast, a machine forecast that is consistently as good as your best human forecast. So that's the size of the prize, especially in the first years. And then as data becomes better and more accurate and more structured, then you can expect more from it. But this is already a very significant improvement. So we're talking about almost one full standard deviation compared to the human forecast. So let's see, what sort of benefits can that bring. So if you put that in the context of human forecast itself, we're trying to provide AI-enabled solutions to help the human forecast improve as well. So it's not really a competition. We're trying to have collaborative tools. So let's see how the human forecast improves. We've clustered them again, looking at a study from 2019 across customers. We've indexed every company's, every farm's forecast accuracy from 2018 as 100. And we will see in this chart the improvement achieved in 2019 compared to the previous year. Lower numbers will be better because we'll be looking at their, so we're indexing their error, the average error. And we have 3 clusters. First of all, we have users who don't really log in or don't use the app or do that very rarely. Then people who use it about once a week, and people who really go in daily. So this is how the numbers look. This is again across customers. So variance for low engagement, basically no change. Medium engagement, more than 10% drop, and high engagement, almost a fifth. So the error of the high engagement group was reduced, the absolute percentage error reduced by almost a fifth compared to the previous year. That is dramatic. So, if you're trying to reduce waste and improve profitability in the company, improve the financial sustainability, this is one of the key areas that can induce shocks into your systems that can make your company inefficient if your forecast is not good. So you really want to lower these bars, and by having this improvement and continuing this year on year, it's a massive, potentially a massive improvement for the companies, for the growers. And the next slide I want to show is a similar sort of evolution slide, but now talking about the machine forecast. So on one hand, where the tools help the human forecasters improve. On the other hand, independently, the machine is learning to improve its own forecast, and this is again indexed to for each application. The 2018 errors was indexed at 100, so you can see the relative improvement compared to the previous year's model. This is obviously we start with a model performing as the previous year, and you see the sort of work we do throughout the year to improve the learning capacity of the model, and then we reap the benefits as the machine continues learning. So we have a new generation model that brought about a 10% improvement by February last year. Then that received some additional training data, and the accuracy improved further. So in March, the learning algorithm didn't change, but there was simply more training data to learn from. Then we cleaned up that data a bit more, and then we got a further improvement, which stayed throughout summer. And then in the middle of the season, we had another review of the learning model. Because we had more data, we were able to introduce more features and stay throughout the season. So you can see about 1/3 of the error was shaved off within one season. And that's a typical improvement that you can expect from a machine learning application. So what tends to happen is that the machine, depending on how much historical data there is, the machine starts off slightly behind the human forecast, but it tends to improve faster. So we try to improve both, help improve the human forecast, but also make sure the machine continues to learn. And at some point, the machine gets slightly better than the human forecast, and in some cases, a lot better. But it's still important to keep those forecasts independent and keep both of them going. And for many of our customers, that crossover point was last year, where the machine learning model overtook the human forecast. So this is just a summary on practically how it works. So if you're interested in a forecasting solution, with us or with, I'm sure that there will be some other companies doing forecast as a service. That's how we think it should work. So there's a system that helps you improve your own forecast, and in parallel, it produces an alternative automated forecast that's more scalable, that can take in more data, and that can improve over time. And that's the sort of results we've seen in our work. And to wrap up the presentation part, and then I'll come back to that point I mentioned about Simon's presentation. How do you get the best value out of this? So the use of AI and the business we're in is more mature than the robotics. Robotics is a very exciting sector that is starting up, has been starting up for a few years, but it's going to take a bit of time to mature. And what we're doing is, in many ways, we're preparing the field for that, because both forecasting solutions and robotics will need access to reliable, scalable, correct data and interchangeable data increasingly. And we do provide that. We do build that capability for our customers in order to provide the forecasting solutions. So how to get the best of AI? Things you should be doing is to have a specific brief. The example I sometimes give is we had a company saying, "Could you build us a forecast for our packing operations, for our ripening and packing operations, because we need to improve 14 days out, and we need something that's better than the human forecast." And we built something for them. The error was half that of the human forecast. And then we presented it to them, and the salespeople were, "Okay, this is really cool. We need this." And then the finance director said, "Well, okay, I'll sign this off if it can build my business plan for next year." So that's not how AI works. It might be how AI works in movies, but that's not how AI works in real life. So AI is very widespread in many sectors, but it does need a very specific brief. What is the problem you're trying to solve? What's the answer you're looking for? And the machine will learn how to answer that particular question. So that's the most important point in terms of recommendations. Then do assign a project leader, someone who can interact with your supplier. By all means, you can try to build solutions in-house, but I'm biased in that respect, so I would recommend looking for outside partners. I think it's going to be difficult to finance a solution properly in-house. And then really discuss the use cases from the start with whoever's building the solution for you. How are you going to derive value out of it? How actionable are these forecasts, so that you can optimize the work to give you the best accuracy for the most actionable forecasts. What you shouldn't be doing is to allow the brief to shift over time. So don't allow what's called scope creep, and don't look for a silver bullet that will solve any and all problems. So these might sound very sort of motherhood statements now, but when you get involved, it's very tempting to say, well, yeah, could we also add this, and what should we expect to get out of it? So just keep it sharp. So that's the presentation about how AI can be used specifically in our case in forecasting solutions, and what sort of benefits you can expect to get from that. Again, we're a young company as well. We've been in this. We've started this market, as far as I know, 7 years ago, and this is the experience we've got so far. But to circle back to the trends part, I started by saying you can have significantly more productivity and improve your yields and so on without improving the corrosion, without increasing the corrosion on the environment, and that's one part of it. But then there is, I completely agree, there is another big trend or another big need, which is system of systems, and increasingly that will be required. And what we see, for instance, now, as we start to work with companies, even at a company level, sometimes it's very difficult to integrate the data from one part of the business to another. And in agriculture, companies are often, businesses are quite complex. So there'll be a partnership for this particular product with that particular pack house, a different partnership for distribution with that marketing company, and so on. So it becomes exponentially complex to make sure all the data gets to the right point and it's labeled, consistently, and so on. So a lot of the work that we do is actually in getting that data all matched up, because that is a prerequisite, as you know, of building AI solutions. So we do use machine learning, and we do just use good computer science to solve that problem. It is a big problem, and I completely agree that over time this will need to grow. And that's, I think, if you're looking for solutions in AI, one of the benefits is that you'll be increasingly ready to integrate in a system of systems. So that would be my presentation. I hope I haven't taken too much of the time, but Wendy, please tell me if you have any questions, and Simon, by all means, challenge me.
That was amazing. I quite like the idea of putting all my data and AI in my washing machine and cleansing it. I don't know if that's a reality yet, but as you say, from listening to both of you, it's a massive problem, but it's also a massive opportunity. There are so many different avenues that people can look at. And yeah, you've both blown my mind with obviously facts, figures, and what you're doing in the sector. So I could listen to you all day and all night. But literally, I have had a few questions emailed in. One of them is a question we get asked all the time. And I'm from farming background as well, so it does resonate personally with myself. And then there's a couple more sort of generic on what we're looking at today. So in regards to the end users in that farming community, the things that resonate with themselves, I say, is in relation to the adoption and the effectiveness of this new technology. And it has to meet three key objectives, which is the cost. So what does it cost? Can I trust the technology, or can I trust you to deliver what you say you're going to deliver? And then what are the results? What's going to be that return investment for me? So looking at what we've been touching on today, perhaps yourself, Mihai, could go first, as in, how long do you believe it will be before those three key areas are actually there with proof of concept and we can see that return on investment?
Yeah, thank you. So I think it's always important to look at cost, and we started this business by defining the service very specifically. Again, we like sharp briefs, so we only do fruit and veg, and that allows us, our solutions, for example, be very very concrete. Our solutions start from £1,000 a month. They can go up to a lot more than that, but they're really affordable solutions, and a lot of the time producer organizations can access them. So then a cooperative can to get a service that all the growers get access to, and so on. So the cost can be very, very affordable. And I think there's also exceptionally good government support for this. A lot of the time, the government will support farmers who invest in innovation, and so there'll be grants and so on. So I think that the cost is something that people are. It's normal that people will be concerned about. But at least in our experience, I don't know if there are other solutions and how much would those cost, but I can tell you how much our solutions cost. The second point was, I think you said, can I trust you? And I think that's also a really important one. So what we've done from the start, I've written that, back in so the last revision of our terms and conditions is in 2014. And they were, they met all the GDPR, norms and so on. I've written them together with our solicitors from the start, so that I'd be happy signing them. So we've made them so clear. It's we're allowing the user, the owner of the data, full control over what happens. There's no funny small print and so on. So that's what we can do sort of legally in terms of terms to show you that. There's also an aspect of incentives. So if we as a supplier of forecasting solutions misplace your data, this is quite bad. So that this has an adverse effect on the farm. So you might feel a sting, but it would kill us. So the incentives are extremely aligned, because if I misplace your data, I lose my business. So that's the two ways in which I can answer that. And in terms of trust, I mean, we work with fierce competitors at the moment. We work with number 1, number 2, and number 4 in the market, and they're all customers of ours. Of course, no one sees anyone else's data. So that's on the second question. And then the third one, I'm not going to fudge, but I cannot really give you a good answer on return of investment. So I can tell you how much it costs, and I can tell you what sort of benefit you can see in terms of the error, in terms of your forecast error. So these are shocks to your system. So if you say, let's say you're a grower, and then every year you get, over forecasts of, I don't know, so many thousands of tons, and under forecasts of so many thousands of tons, or tens of thousands of tons. Those are shocks to your system. If we reduce those errors, you should be able to benefit from that. But that is somehow outside. We want to help growers and distributors get those economic benefits, but we cannot claim those benefits as being our own. And I will not venture a guess. But if you look at the scale of the problem that we're trying to address, you look at the scale of the improvement in terms of error reduction. I think if you're in the business, you can venture a guess or an estimate of how much that would mean for your own business.
Fabulous. Yeah. Simon, perhaps you can, because you cover quite a wide array within your presentation. So somebody's asked me, is there innovative technology out there now that meets those key industry needs?
Oh, yes. Yeah, absolutely, yes. And we're really at the starting point in the adoption of a lot of these technologies, whether it's robotics. So the Saga robot system I showed on my last slide, there's 3 of those now on beta test in Kent. We've got some big Innovate UK projects about to start to demonstrate these systems on a larger scale. The Garford farm machinery robotics system, they're widely available and have been for several years. That's robotics. There are other systems globally on weeding robotics which are coming in. There's very wide-scale use of Internet of Things across the food chain, very wide-scale adoption of AI, machine learning, vision systems. They're all really coming at pace. What we really need now is really lots more data on what I call demonstrable and reproducible ROIs. So we've got to go out to business, and we've got to now start to shout out what we're actually returning for the investment that these techs need. And Innovate UK is playing a big role in that. So they're funding a number of demonstration projects to try and get that evidence base. And when your first question about trust, it's really crucial. You've got to trust each other in a very deep way, but you've got to trust each other's data. And part of that data set is going to be those ROIs. So it's the financial numbers that are underpinning these business cases. And then once we get that out, I think that we'll start to move, and we're going to scale very, very quickly in this sector. When I was started in Agrirobotics, I was asked by many people, when are these robots going to come? And this is about 2-3 years ago, and I was saying, well, 5 years and 4 years. Actually, with COVID now, we need to start to get these robots into industry almost next year. The whole thing has accelerated, and all the research is accelerating, and we need to get these systems out to industry really very, very quickly. The demand is absolutely there. But we can't. We need to do every step carefully. We can't rush it. We've got to get the tech right. We've got to demonstrate it right. And back to what I said before, you've got to have those ROIs. We've got to have those demonstrable ROIs to convince industry to buy that tech and use it. So there's quite a way to go, but the journey's it's going at a great pace at the moment, and it's accelerated because of COVID.
You've answered the next question already in that one, because I was going to ask who are the influencers or enablers that are going to bring those technologies together. So you've quite nicely answered that with getting out onto farm, getting those demonstrators, enabling people to see, say, the return on investment. So I think this is one for both of you, because it relates to both you as a startup business that's actually on the ground doing it, and then yourself, Simon, with the research you're doing. What are the next steps for the agri-food, agri-tech industry? Who wants to take that one first? Go on then, Mihai.
Thank you for that. How would I put that? So I think I would look at two things that are really going to help. I think one is collaboration. So we've got very complementary capabilities across various organizations that work in this space. So there's a range of universities, early stage startups, startups which are a bit later in life, like us, and so on. So, and the incentives are can be quite different. So sometimes an early stage startup doesn't really look at profit. They need to prove something quickly, or they're gearing up for the next investment round. A business like ours is a business, so we need to keep an eye on the P&L and so on, just make sure that we stay profitable. And a university, again, will have completely different objectives. So I think finding ways to collaborate when the incentives are so diverse is difficult, but it's worthwhile. So we've got a couple of discussions with various companies. I've put out a little manifesto in terms of how data sharing can work and how collaborations can work. And it's really just 3 points. The data owner should have the on-off switch, privacy without the small print, and no commercial incentives between the parts. So everyone can hold its own, protect its own IP and so on. There's no funny business. But I think collaboration is really a big one, because there's so much going on sort of in Simon's head and in his team and in the companies that he's working with and the other universities collaborating with, and in a company like ours and so on, and of course in our customers. So I think that's the first big area, collaboration and doing that right. The other point is probably managing expectations. So just maybe that's the right way to put it. I think it's very tempting. Again, it's very tempting for startups sometimes to put out some big bold claims. But I think for us as a sector, as data geeks who are trying to help agriculture, it's really important to keep those claims under control. So to make sure that we over deliver and that we retain that trust that growers and distributors put in us, because this is a marathon, is not a sprint, and we're not trying to solve this overnight, but we're trying to build a system, a process, a graph, or a set of relationships between entities that allow us to gradually solve this going forward. And I think, for that trust to work, is really important that none of us sort of overpromise, because that can lead to wrong expectations from ultimately the farmer. That's what I feel are the two big topics. I'm curious to see what Simon's view is.
Yeah, I would. It's very easy in these conversations to start to pick winners. I don't particularly want to do that, because I think the opportunity is so great within this space. All I'd say to the tech community is seize the moment. I think there's a brilliant moment to seize here, and and that's been around the environmental needs. It's been around the Brexit needs, COVID needs. The pace is really, really accelerating. So all I'd say to the committee, seize the moment, because there's a fantastic opportunity in the agri-food space in the UK, because the domain is very professional, extremely well done, and I think it's absolutely world leading. And I think if you can get your tech applied in the UK and get those ROIs, those reproducible ROIs, you've then got a great springboard to go, not just in the UK, but to go across the EU, globally, and wherever. So I'd say seize the moment. If you don't seize the moment, someone else will, and that's my fear. There are many people globally developing these tech solutions, and I don't want the UK community to be a buyer. I want us to be a seller. So seize a moment, and as I said, there's lots and lots and lots of opportunity out there to get into this space.
Yeah, I agree totally, and I revert back to what I said was my vision at the beginning, which is to support the UK food supply chain to become the most sustainable ecosystem in the world through that demystification of the technology and encouraging that collaboration pan supply chain. So you've answered those absolutely admirably, the pair of you, and I can't thank you enough, both for your time and hopefully, apart from educating me, educating the people that have joined us today. So Mihai, Simon, thank you very much. And I look forward to catching up with you again soon in the near future. One thing that is very, very important to both myself and the AgriTech program that I work under within Eagle Labs is your feedback. So at the end of this presentation, there will be a slide with a link on it and a QR code for you able to provide that feedback. There will also be the link within the YouTube page if you happen to be watching this later on, because this will be available, let's say, at a later date within our YouTube channel. But first and foremost, I say thank you both. I've really enjoyed tonight, and I hope you've enjoyed it too. So yes, thank you for helping me demystify Industry 4.0. and more importantly, running through the future outlook for agriculture through the use of AI and Agrirobotics. Thank you both.
Thank you, Wendy. It's great to see you, Simon. Thanks.
Yeah.